Test. All right. Time to get started. Let's turn this guy off so I don't lose a finger. All right. So, if anyone watched my last video, on Saturday we built this. This is the base that we built. I built all of my armiger bots off of. Just to review, this has got inside of it. This is a bit awkward. It's got the battery, the charge controller, and booster circuit, and then it's got the microcontroller. Last video I wired all this up, showed how to do it, tested everything out. It works. So when I flip this little switch on the front here, I don't know if you can see it closer. There it is. When I flip that switch, the whole thing turns on, the microcontroller boots up, and we get power. So if I can do that. Oh, the battery's disconnected. That's not going to work. Yeah, I don't leave these batteries disconnected when I'm not attending, just because they're lithium polymer, and you know, there's no need to leave those plugged in. It's just a bit safer to leave them unplugged. Lithium batteries being what they are, these things can be a little bit irritating to plug in. There we go. All right, so yeah, when I turn this on, we get power, and then you can see the little light on the bottom of the microcontroller changing color. It's this little board here. That is the brains of this entire operation. And yeah, so we built that last time, and now we're actually going to do something with it. I'm going to turn this off for now. For the stream, I built some armiger bits, because I know everyone wants to watch me super glue GW plastic together. Oh, we're still in starting soon. Hold on. There we go. So I have with me 2 pairs of legs, or a pair of legs, I should say. An armiger torso, and 3D printed parts to mount the servos in the hips. So basically, the main bits are going to be here. And we're not actually using the torso or the waist bits from the model. We're going to be replacing it with this servo right here. Just a SG51R micro servo. And then we have this replacement hip that is designed to take the servo and basically do this. Let me get this right. It's a 3D printed part. It slips right over, allowing the servo to go through. And we've got a ring bearing here that's going to go in this little socket. And then we have this piece here, which connects to the shaft of the servo, like so. I have to trim it a little bit. And when the servo is activated, the whole thing rotates. and the torso will sit on top of this little pedestal here. And yeah, that's all there is to it. These little sockets on the side, these little round things, that's where the legs go. They fit right in to the little socket. It does take a little bit of gluing. I might use hot glue for that just because it fills a gaps better. But you can use super glue as well. So we're gonna kind of assemble this whole thing, and once we have it glued together, this might take a few tries. What we'll do is take the wiring and run it down one of the legs into the base, and then we're going to solder it into the microcontroller. So we're going to see a working robot tonight. It's just going to be the legs with a little torso on top. I mean, I'm not going to build it out any more than that on stream because that would take a long time to paint it and everything. So I'm just going to show you how to build this out, get it rigged up to the microcontroller, and then, yeah, we'll probably, maybe if we have time, I'll hook up the LED in the head of the robot. But we'll see how far we get. This stuff, everything about doing these takes longer than you expect. So let's get to it. All right. So I'm going to clear the base and the legs over here. First thing we're going to do is build this little assembly here. So I've provided the STLs for this. Let me get that link for anyone watching on Twitch. Where is it? Hold on. I have to go to my YouTube posting of the last video to find that. Give me one moment. If I was a wise man, I would have this ready to go, but I am not, so. All right. Here we are. Hold on a second. That is not the right link. That is a YouTube link. I want the GitHub link. All right, I'm putting it in chat right now if anyone's interested. This is going to have all of the STLs that I'm using for these projects, and there will be more. This assembly here is the one that I'm building where the servo to turn the torso is in the hip. I also have a design where the servo to turn the torso is inside the torso. So that's a very clean build. It's you don't see the servo. But when you're building it with a servo in the hips, you have all that space inside the torso to do other stuff, like add sensors or a camera or literally anything you want to add up there. The microcontroller that runs this thing is a very small computer, can do a lot. So I like the ones with the motor in the hip, just because it's, first off, they're easier to build because you don't have as many wires rotating into the torso, and second, I like adding stupid shit to the into the torso. I call it the payload space because that's where you can actually put stuff. But we'll build this one first and see how that goes. So, like I said, the first step to building these is to build the hip assembly. So we're gonna encase this we're going to put this, I call it like a saddle mount because it kind of sits on top of the servo. On top of here, we're going to build and get this thing calibrated and assembled. And then we're going to glue the legs on it. And that is, yeah, then we'll have a robot. That from there, we'll go and we'll zero the servo, which is extraordinarily important. Don't ever glue anything into a servo or fix anything into a servo without calibrating it first. Otherwise, you're going to be sad. Yeah, let's get started. Okay, so the first step is, you can see this servo has these little screw-on ears. We don't want those because we're not screwing those in anywhere, and they just stick out and get in the way of actually gluing on the armor plates, like the groin plate of the Imperial Knight. So I'm going to chop this off with some clippers. Get the one in the back too, because there's on each side. All right, so that's what this looks like now. I've clipped off the little screw-on tabs, and let me get a X-Acto knife, and I'm just gonna. There's always going to be a little bit of like a plastic ridge here from where I cut. I'm just gonna kind of. You could sand this off, but I'm just gonna X-Acto it off. It's not terribly difficult. You don't need to get all of it, just kind of get most of it, so that it's relatively flush with the rest of the housing of the servo. Because we are going to be gluing stuff on either sides of this at some point during the build, so we want this to be as smooth as possible. All right, that's good. And then we do this side. Yeah. All right, so this is 3D printed resin. You could print these with yeah, I mean, you could definitely use a fine grit sandpaper or like a medium grit sandpaper. It doesn't really matter. In fact, if you scuff the surface of these things, that's actually probably a good thing, because the paint will adhere to it better. Yeah, this piece, all the stuff that I'm using that's 3D printed is with 3D printed resin. I use an Elegoo Saturn 3D printer. It's really, really great. You could do this using the thermoplastic. I can't remember what the acronym is. The ones that the traditional filament-based 3D printer. That would work just fine. One of the reasons why I have a ring bearing here is so that you can print with 3D with the filament-based printers. This will reduce any friction at all that occurs between this part and this part that sticks through it. So if you printed this out of filament and it had the filament pattern on it, fine. You've got a ring bearing. So what we're going to do is we're going to take this little ring bearing, and this all the ring bearings and motors and everything that I'm using here, if you look at that GitHub link that I posted, and if anyone needs it, I can give it to you again. That has the complete parts list of everything that I'm doing here. So what we're going to want to do is we're going to take this ring bearing and press it into the fitting. You want to be gentle with the sides of this thing, because this isn't actually a very strong piece of plastic, but you're going to take this and really push this in here and kind of eyeball it to make sure it's sitting flat, because if it's not sitting flat, it's going to be a little bit weird. I may have some... I'm just going to take the screwdriver and pull this out. Just check to make sure I've got no support debris in here. It looks good. Sometimes this fit can be a little bit finicky, but you really want to press it in so it won't go in anymore. Make sure it's even, like it's not lopsided or anything, because that's very important. You can even use some pliers to really press it in. Like this side is slightly higher than the other side, so I'm just going to put some force on it. You just don't want to break off the sides of the saddle. Yeah, I mean, you can heat resin up to make it expand, but when you do that, you run the risk of it not cooling down the same shape it was. That's particularly a problem with Forge World resin. But yeah, it's easy enough. You're just gotta give it a little bit of encouragement. Yeah, so that's flush. And yeah, it's ready to go on top of the servo. So if you print this out, you'll notice that the ring where the washer, where the bearing sits, is slightly offset from the rest of it, and the hip joint, the little cups for the hip, they should be directly in line with the opening on the top. So the way we want to do this is we have the servo. We want to set this up so that the sides of the saddle are kind of flush with the front of this. So the ring will with the bearing will sit a little bit off the front of the servo. That's by design, because we're going to have, if you know what an armiger looks like, you're going to have that armor plate that's kind of green stuffed or glued onto the front of here, and we don't want it to be kind of sticking way out. And the way this is designed, the top of the armor plate will kind of go directly above against this top piece, so it fits really well, even though there's not the groove to mount it that's on the GW model. All right, so this is just sitting on top of here. It's relatively loose. You can move it around, and that's by design. We want this to, at this point in the build, we want this to be loose because we want to be able to kind of slide it in and out and adjust it as necessary. Because if you can see, I don't know how well you can see that inside there. We want the spindle of the servo or the shaft of the servo to be as close to the center of the bearing as possible. It doesn't necessarily need to be, you don't need to get out your calipers or anything like that, but we want it to be close. So the next step is to take this piece and kind of push it onto the spindle of the servo. Now, if you're using resin, the most resin will contract a little bit when it dries or when it cures. So in order to get this to fit, we're going to need to change. We're going to need to drill it out a little bit. So I'm going to get my drill bits and find one that actually is near the diameter that we can use to just bore out a little bit of this material. It doesn't really matter if you bore out too much and it's just a little bit loose once you put it on the servo. But you don't want to bore out too much because we do want some strength in this piece. So maybe just like 1/4 of a millimeter, just so it kind of sits on the servo snugly. That's where I would say that the sweet spot is. And this drill bit is way too big for this finger drill. Well, I'm gonna get it in there, or not. What else I got in here? Ah, that'll do. So we're gonna take this drill bit, and we're just gonna kind of put it in here at a slight angle, and just kind of grind a little bit of the material out. And you might have to do this a couple times. You don't want to just make sure you're not taking too much. So just do it until you get some flakes coming out and clear that out. Just tap it out. If you're doing this a lot or if you're sanding resin, make sure you wear a mask because this stuff, you do not want it in your lungs. It's not toxic, but it's also microplastic, and if it gets in there, it's not coming out for a long time. So it's really, trust me, it's not great to have that in your lungs. You'll be coughing it up for days. So I need to take a little bit more, and your hole doesn't need to be perfectly flush either. Oh, that's not good. I may have damaged this piece. There's supposed to be a smaller diameter hole inside this to hold the screw, because I was doing it on the wrong side. Yeah. Okay, well, hold on. Yeah, I accidentally drilled out the piece, or it wasn't printed properly or something. I've got a spare, so that's fine. Some of these pieces can be a little bit delicate, and it's just you gotta kind of feel it out to make sure you're not doing something dumb. All right, that is the spare piece. Let me just make sure it's looking good here. Yeah, all right. Well, the good thing about 3D printed stuff is if you break it, you just make another one. I'm just going to sand the supports columns off this one so it's smooth on top. All right, let's try this again with less breaking of things. You can also take an X-Acto knife and just kind of shave around the edges here. Just don't do what I did and cut or drill through the. You can't really see it because the camera's not going to focus. Oh, there you can use. There's a small inner diameter ring in there, about 2 millimeters in. Just don't drill that out because you need that there to hold the screw. So just be gentle with it. and you just want it to kind of fit on top of the. You want the shaft to be able to kind of be able to go in there. And this, you know, when I was making these STLs, I probably should have made them a little bit, the aperture here a little bit wider, but I didn't. So now I have to do this. But it's not a big deal. And this will take a few tries, but you can usually tell when you're getting close. It'll just kind of push on there. But I want it to be a little bit looser, because we are going to have to add some super glue to this eventually. But we're going to zero the servo first, and I'll explain what that means shortly. If you fail to zero the servo, you'll end up with a limited range of movement that your model can make on that axis. Okay, so that sits on there relatively well. A little bit tight, but I'm just going to give it a few more goes with this. All right, that should be fine. Yeah, that'll do. It'll tighten down eventually. It'll loosen up. Yeah. So as you can see here, we can push this down. It's probably not going to go all the way down, nor do we want it to. But as long as it can kind of flex on there, or you know, kind of sit on there by its own tension, that's fine. So again, we're going to take the saddle piece and put it right on there. Try to line up the shaft so it's in the center there, and then we're going to take this and we're just going to kind of press this on here. So it looks like this. Believe it or not, this is all the 3D printed pieces in one of these robots. Everything else is GW plastic. That's one of the reasons why I like these armigers, is because they're so simple to build. The legs just pop on these little sockets here, and the torso just sits on top. We are stripping out some of the. We're not using some of the. We're not obviously not using the waste assembly from the real model, but you know it's right on top, so no problem. All right, so you'll know you've got it on well. You may not be able to hear this, but you can see that this is actually rotating the servo. So the gears inside are actuating right now. And what we need to do now is we need to zero this guy, to zero this out. So I am going to grab my trusty servo zeroing mechanism here. Just gonna got some extra wires and a transistor on here because I was building a laser boost circuit using the same setup. Just gonna verify that everything is good, and I'm going to plug this in. What this thing should be set up to do is to. This is the same microcontroller that we're using. This one right here is the same microcontroller we're using in the robots. This one is a I2C PWM 8-channel controller. So what this does is you've got these pin blocks here. You can attach servos to these and control them using the microcontroller. When we're actually building the inside of the robot, we're going to be using controlling the servos directly from this, because this does have some pins that can control microcontrollers. Hold on a second. I'm just making sure I've got the wiring right on this. Hopefully this will work. If it doesn't, I'll just wait. I'll just wait for the calibration step until we have the. Okay. So let me open up the microcontroller editor. This is an app called Moo. I'm starting it up now, and I'll switch to it once it's ready. For some reason, it likes expanding to all screens, so that's kind of obnoxious. All right. Okay, so we've got Moo. We've got CircuitPython. That should be the one running on this, on the microcontroller. Let's make sure. Yes, okay. So as we can see here, we've got just some very basic code. Oh, this one was being used to test laser calibration for the other model. So we don't need that code. Just going to uncomment all this other code here. So what this code will do is, oh, actually, I don't want this either. Well, it'll be a fun demonstration. What this code will do is this does two things. When I comment out this whole while block, this will switch the servo from 0 to 180 position just once a second. It'll just go back and forth. When I comment out that while block, it'll just zero it straight to 90. So let me plug this in to make sure this is actually working. Let's see what channel I'm using here. Server kit channel 0. So there's 8 channels on this. I just need to make sure I've got the right one and that it's oriented properly. Okay. So this should do something immediately. Come on. Okay, so got to reload the code. Something might have gone wrong. I pulled a bunch of wires out of this thing, so it may not be working, but just give me a moment here. Ah, here we are. Yeah, that's it. I made an error. Let's see if this will work. Yep. As you can see, our little servo is doing things. So we've got the right now it's just switching from 0 to 180, and it's not an actual true 180. If you look at the orientation, it's like 165 degrees or something. It's not entirely going all the way from 0 to 180, which is fine. You know, you've got these are relatively imprecise devices, but that's fine. So what we've got here is just the mechanism working, and I just want to look at it to make sure it's flush and that there's no signs of stress, like the saddle part isn't wiggling around when this thing rotates. So yeah, just because the goal here is to have this so that the rotating piece is not rubbing against the bearing or causing the housing to move around. So right now it's looking pretty good. It feels pretty solid. When I put my fingers on it, I don't feel any movement. Just double checking to make sure everything's good. Okay, so once that's done, once I'm fairly confident that this thing is a happy mechanism, I'm going to disconnect the power from it, and I'm going to glue the saddle parts down. So that's just going to be regular super glue. I like to use this blue Loctite stuff. It's this stuff. It's like the gel stuff that it doesn't bond immediately, and you've got a little bit of time to play with it before it sets on. So what I'm going to do is I'm just going to lift these up just a little bit and put some glue in the crack. We don't need much. We'll have an opportunity to glue some more later on, but just lift it up with your fingernail or a screwdriver or something and just kind of put some glue in there. Or you can even just glue it along the sides. Just smear some glue along the edges like this. We just want it to stay put. Try not to move the saddle too much when you're doing this. You can put some, just make sure the saddle's flush with the housing on all the sides. You don't want it riding up a little bit. You can put some, you can put some glue up at the top here. Just make sure whatever you do not get glue into the servo, or you don't put glue. You don't glue the shaft of the servo to the housing, stuff like that. It's surprisingly easy to do. Just be aware of where your glue is going. So, I'm just going to give that a second to dry, to harden a little bit. Just verify that you can still move. You can still move the gear, and that you're not, now that you've kind of moved the saddle around a little bit to glue it, you're not causing any major friction. You'll know you're causing major friction if turning this piece causes the housing to kind of buck a little bit or move around. You don't want that at all. So this looks good. I'm just going to give it another moment to while this is setting. This cable is wound around a little bit. I'm just going to turn it so that I can set down. All right. So while that's setting, I'm going to modify the code a little bit here. So I'm going to comment out all of this while loop stuff. So now what the code will do when I load it back onto the microcontroller is it will just set the servo to 90. And I'm going to put a little sleep command in here because sometimes there's a bit of lag between when the microcontroller processes the command and how long it takes to send to the servo. And if the program ends and deinitializes before the servo gets the command, it won't do anything. So I'll give it a second after I give the command to do its thing. But the reason we want to calibrate this to 90 is pretty simple. Okay, so I'm gonna glue my fingers together here. So we've got the torso, right? And so like you get this thing together, you get it attached to a microcontroller, it starts moving. Oh, you're like, oh, this is awesome. I'm gonna make a robot. First thing you do is do this. You change the servo so that this looks like it's in the right alignment. You put some super glue on it, then you go splat. Put this guy right on top. You go, I got a robot. That's awesome. Yeah, it is awesome. Except for the servo, you put this on without calibrating it. So the servo, you think it's pointing this way, but it's actually pointing that way. And now your robot will only do this. It'll be on sideways. So you really want to, once this glue dries, I'll take the spindle, the top part off. We'll set it to 90. Then I'll put the top part back on, super glue it in, and screw it in so that everything is assembled. Calibrating those servos will make sure that you have the full left and right 90-degree range of motion, rather than having to limit it to be like 30 degrees in either direction because the servo is pointed 90 degrees offset or something awful. So I'm just going to let this dry for a little bit longer. Put this down in a way that it can actually sit down without having to try to flip over on me. But yeah, while I'm waiting for that, this setup is just a little the microcontroller I use from the robot. The robot's attached to a breadboard. It's powered by a USB-C, which I've got connected to the computer. when you first use these, you have to put the Circuitpython firmware on them, but that's just a matter of pressing a button on here, connecting it, then dragging and drop a file. Easy as that. Now that I have that Circuitpython in, I've got on this side power and ground, and then I've got on this side an I2C bus. It's just 4 wires going over to this piece here. This piece is a servo / LED controller that can do 8 channels. And the code that I had on the screen earlier just tells this thing to set channel 0 to 90 degrees. So that's what we're doing. That's what we're going to do. So just for demonstration purposes, this is the way I've got it. It looks like it's aligned, right? It looks. We want the grooves on the side because those align up with this. On the bottom, you can kind of see there's like these cylindrical parts on either side of the aperture. We want the grooves to line up with those so it fits snugly. So it looks like it's aligned, right? You put the thing on there, it looks like it's aligned, but it's really not. So let's see if we can see what true 90 actually looks like on this. So I'm going to connect this back, and this thing will probably twitch. So let me just do this. Okay, so it's running old code. Let me refresh. It's running the old rotation test code. All right. So, we got pretty close, but you can see it's not quite perfect. So we were when before we calibrated it, this was dead on, but now it's like maybe 10 degrees off. You could build the robot just fine like this. But what would happen is it would always, and you just tell it to center it at 10%, at like 10 degrees rather than 0. But you'd lose, it would always turn farther in one direction than the other. So what I'm going to do here is take this piece off and put it on to match the orientation. And you want to be very careful doing this to not turn the spindle if you can. Just, there we go. So I'm going to rerun this program just to make sure there's no extra rotation that I added when I was pulling it out. And it looks good. Okay, so I'm going to leave the program running because the program will hold the servo in place. So if I accidentally add some twist to it, it won't. It'll try to resist, so it won't twist as easily. So I'm from the overhead view. Let me find my mouse pointer. There we go. From the overhead view, I'm trying to keep this as lined up exactly as possible. So and I'm just going to press it in. It's very difficult to press these in without adding, a few degrees of twist to it. That's fine. You can see that it's a little bit canted, but in the grand scheme of things, we're never going to be rotating the torso a full 90 in either direction because we don't want to overstress the cables in the back. So we can have this be the center and just give it like a 3-degree cant or whatever. That's fine. So what I'm going to do now is press that on pretty good. And I'm going to get the screw. Where did that go? I'm going to take the screw. I'm going to put a little tiny bit of super glue in there, and I need to get a screwdriver ready to go quickly because that sets very fast. We just want to properly bind the shaft of the servo to the screw to the fitting as quickly as possible. All right, that'll do. So, and just keep in mind that once you do this, you're pretty much committed. So make sure you've got the alignment correct. All right, so there's glue in the hole. Very quickly, I put that screw right down in there. And it might take some pressure to kind of get it through the resin. The screw hole might not be all the way open, which is fine. Just a better screwdriver for this. It's too big. Yeah. Just screw the screw in until it doesn't want to go anymore. You're actually screwing the screw into the tip of the servo shaft, so it binds in pretty well. I've never had any of these shear off before. The combination of this being relatively tight, the screw and the glue will keep it on there well. So once you've done that, I'm gonna disconnect this from power so I can actually disconnect this from my test rig so I can actually turn the servo. You want to make sure that this is tight. You want to make sure that the glue that you put in here didn't kind of seep into the mechanism. So as you can see, that works pretty well, and it's on there now. Like it won't. It would take some effort to get this off, if it's even possible. I mean, the thing is, this entire assembly, the servo, the ring bearing, and the resin probably costs maybe $15 total, if you count for everything. So if you screw this up, and you might screw up a few of them before you get to the hang of it, you know, it's not a big deal. Usually I buy these servos in big packs of 10, and the ring bearings come in 10 packs. So yeah. And you don't have to screw the bearing. You don't really want to or need to glue the bearing in, because it's going to be pretty snug in this collar, and if it comes loose, it doesn't matter because it's held captive by these two pieces. So the reason we use the bearing to begin with is, if you look at the way it fits, you can't see it through here, but it fits very snugly into this setup, and this platform here, the spinning part that holds the torso, runs directly through the center of the bearing. So basically what this does is it adds a lot of strength to the model. Yeah, you could probably take something like this top piece and glue it, just stick it directly to the servo, but you know, you'd have a lot of you'd just be relying on plastic to keep it together. This way, if this gets yanked back and forth, or like pressed on, or it gets some sort of shock, it's going to hit the ring bearing inside of like 1/2 millimeter. So it's going to be a lot of extra strength. You won't risk damaging your gears or shearing off the screw, or a whole bunch of things that can happen if you just bind these together with plastic. So the bearing it's basically your safety net for knocking the model around. Because I build these things to play with them on the tabletop. So I'm assuming they're going to get dropped. They're going to get, you know, abused. So we want to make it strong. All right, so what I'm going to do here is I'm going to stick it on my on the test rig one more time to push it to 0. Yeah, to like maybe a 1 or 2 degree turn there, and then I'm going to go find my Sharpie marker, wherever that is. So I'm going to make a little notch or a little mark right in the front of this servo, just the ring and the top. So that's the front, and that's the front. This is our. You can see them. This camera's all weird. You can see the marking here. That way we know that it's facing forward. So if it gets turned, because it will get turned, we know that when we finally glue the top of this robot on top, it will be zeroed. So okay, that's cool. That part's done. You know, these assemblies are very strong, so you really don't need to worry about jostling around. I'm going to move this test rig out of the way. We're done with it for now. Okay, so what do we do now? Well, I'm going to get a drink of water first. And I'm going to heat up my glue gun, because I think we're going to glue the legs on. We want to have a robot. So get this thing ready to rock. Now you can do this with super glue, but because I didn't build these little connectors here, these are just like inner spherical. They're not quite the same as the contact point on the legs. You can see that's got some features on it. So what we're going to do, you can do this with super glue, but you've got to clamp it. So what I'm going to do instead is try to see if I can do this with hot glue, and then reinforce it a little bit with super glue. You know, put a little dab of hot glue on there, press that in, and then put around, like, kind of seep around the edges or get around the edges with super glue, because we want this to hold steady. So I'm gonna take these little legs, make sure I have them oriented roughly correctly. Wait for this glue gun to heat up, and then we're going to glue it in like so. You want the cable, you can see the cables here, to be pointing out the front. If it's like this, I mean, you can do that, but you're going to have the whole, you know, the servo, you're going to have a lot of servo poking out the front. I mean, if you want your robot to be packing some heat down there, that's fine, but it looks weird. It makes it so you can't, it makes it so the front, the armor plate, the cod piece on the finished model sticks out farther than it should. If you glue it like this, you're going to have a lot of, you'll see later, but you'll have a lot of this sticking out the back of it, but it looks fine. It looks just like part of the robot. Once you spray paint this entire thing silver, or whatever color you want the understructure to be, this blends in very well. It looks roboty. That's good enough. So let me see if we're heated up enough. Yep, we're good. All right, so because we're doing hot glue, we got to be quick with this. And we want to make sure, you want to set the legs standing. They'll stand on their own, and make sure they line up when you're pressing the glue in, because this is going to be the final pose. I know there's a lot of people out there that like making custom poses for their models. That's fine. I'm not doing it with this one, just because there's enough complexity here to not want to deal with that. So, all right, so what I'm going to do is take this hot glue, make sure I have some fresh stuff, put a little glove in there. Come on. There we go. Just really, like, you've got to be aggressive with the timing here, because this stuff solidifies very quickly. Hopefully I got hopefully I got a little bit of a contact there. Yeah, I mean, I got enough. It's not really solid, but the super glue that we'll add to reinforce it will make up for that. All right, so I'm going to add a little bit more glue on this side, because I don't think I added enough on the other side. All right. Come on. And the important thing here is that both feet are on the ground, and the servo plate is facing mostly straight up. Now I can tell that these legs, because it's hot glue, the legs aren't like hard attached. So we're going to firm these up a little bit with super glue. I use a different super glue for this. Let me see if I can find it. This stuff is same brand as the other, but it's also much more liquid, and it tends to seep into things much better. Like it finds cracks and goes into them. Keep this stuff away from your servo, because if you get this in your servo, you're done. Your motor's ruined. So what I'm going to do is just right around the cracks here between the resin and the plastic, just kind of very carefully squeeze, assuming this isn't empty or dried out. Yeah, it's done. Let me get another package of that stuff right here, I think. Yeah. For once in my life, I'm prepared for something. All right. Nice fresh bottle. All right. So, like I was saying, I'm just going to take a drop or two of this stuff and just kind of introduce it into the gap between the GW plastic and the resin. You don't need much, just a drop. This stuff will seep into the gaps between the hot glue and the plastic and fuse together. And you just want to kind of add a drop or two here and there, just and watch to make sure it absorbs into the crack. And that stuff will set just like regular super glue pretty quickly. Again, just make sure you're not dripping this by accident anywhere into your servo, because then it's sad times for everybody involved. Yeah, it's very important not to use the liquid stuff to glue the screw in. That is that'll end your project pretty well there, because the glue has the potential to seep through the screw hole into the servo itself, and then it's gonna not turn anymore. Or if it turns, all your gears will be screwed. It'll just be a mess. So yeah, we've got ourselves a pair of legs with a servo in the hips. This is the robot, really, because what's really going to happen after this is we're going to set the head on top, and we're going to run these wires down this back leg here, or one of the legs, and what we're going to do is we're going to run a few wires up so that we have power to run LEDs in the head, which the head, for those unfamiliar, connects up right here. You just drill through the head to put the one LED in the eye, and just right through the backing here, and then you've got plenty of room inside here to work with payloads, as I call them. You put other stuff inside. I've got a design that has servos on either side where the arm sockets are. Those are the ones that I've showed you, like this guy here. Where did he go? Oh. Like this one here. Come on, camera. You can see, if you look carefully, now that we know what we're looking for, this piece right in here is a servo. You can see that structure that looks just like the blue piece that we just put in, because that's exactly the same part. And I've got these custom side panels that I built with a 3D scanner of the original Games Workshop plastic, because the original plastic looks like this. There's no servo box there. So I scanned that, rebuilt it in a 3D editor, and added these little servo boxes. It just makes it so you can stick servos out the side of it, as well as the hips. And this one has the one servo in the hips. You can see it behind the armor plate in the waist, with the cable curled underneath of it, directly underneath, and then it's got the two servos in the arms. The one we're building here is just going to be the one servo in the waist, mostly because doing something like that with the two servos is a little bit. There's a circuit board in the top of the head that controls a lot of that. It does voltage distribution. It's just a little bit more complicated and kind of beyond the scope. But you can use everything you learn here that we're doing here to make that happen. It's just a little bit of an extension and a little bit of electronics. So yeah, I'm just gonna make sure This is cured, has a little bit of time to dry. Yeah, you don't want to break the legs off these things because it's eventually the resin will get crusty and you don't want to have to keep applying glue to it. So while that's cooking a little bit more, we're gonna look at our base. We've got this put together. We've got all the wires here. Everything's looking good when we turn it on. All the lights come on. The microcontroller activates, which is great. We got it first time. So we're gonna want to see kind of what we want to do with this base. You want to make note of where everything is. So usually I like having the robot stand kind of directly in front of the switches, the switch and the charge port, and you're going to want to look inside to see where his feet are going to be relative to the microcontroller. We don't want him to be standing directly on top, not because of heat or anything or interference, but because we're going to be drilling holes right at where his feet meet the plate, and we don't want to drill through the microcontroller. So yeah, just make note of it, and kind of figure out if you want him standing to the side or if you want to put a tactical rock up there for him to stand on. You can do whatever you want. Really, you can pose the legs however you want, just as long as you get that, as long as everything connects up to the servo saddle piece that we printed. So let's go put him right here. Pretty standard. Where you kind of want to make sure he's centered. The switch doesn't, and the switch and the charge port don't need to be directly behind him. There's no reason for that to be necessary. But yeah, I'm just going to put him like that. And you can paint all this stuff back here, the charge port, whatever color you want, just as long as you don't gum up the actual USB connector. So next step is to glue his feet to the plate. Just for the sake of simplicity, I'm going to keep him basically in a mono pose. Get rid of all this glue filament. Hot glue, this is awful stuff. All right, so I'm going to glue him down, and once we are all dry, we can start the fun part, which is running wires and soldering. Really, building the base on these things is the part that's the most difficult, because there's so much wiring and soldering. Once you get that microcontroller responding properly, and nothing catches fire, we've already won half the battle. So I'm just going to orient this guy. You want the servo to be kind of like center of mass here. So I'm kind of, all these plates have this little dimple. I'm trying to kind of eyeball it to make sure that the rotation is over the dimple. Just, you don't need to do that. It just makes sure that, you're not, if the rotation is like too far to the left or right, and you've got these big guns on it, you'll rotate you'll have guns swinging around off of the circumference of the model, and it's a little bit. It doesn't really matter. It's just an artistic thing, but So I'm going to press this guy's feet down just to make sure the glue bonds to the plate. It usually doesn't take more than 30 seconds, and there's always going to be a little bit of like, one of the legs will be a little bit higher than the other. You just kind of got to press it down because, we're not using GW parts where the hip joints lock into the, to the hip assembly. So it's going to be always slightly off. Yeah, he's on there. Just going to clear up some more of this glue filament. So yeah, we're getting there. So what we're going to do is take this cable and fold it down underneath the servo, because this is the front of the robot right here. You can see the legs are oriented, front ways. So I'm going to take this and kind of curl this down below and make sure you're not flexing anything, because super glue can be dry until it's not dry and it snaps right off. So So I'm just going to do that and kind of press it so that it's producing as little of a nub here as possible. I'm going to put some super glue on the cable, on the underside of the cable itself. And then I'm just going to kind of give it a little tug and just adhere it to the bottom. And you want to make sure you're not putting too much pressure on the legs, because, you know, even if the super glue is initially cured, it's not fully cured, and it can snap off. That's the only downside of these designs, is the legs, attaching the legs to the hip assembly can be a bit finicky. Super glue bonds to resin really well, but the insides of these hip connectors are very smooth. You can like score them with a razor blade or run some sandpaper on the inside there to give the super glue a bit more purchase. But because the joints for the hips are on the GW plastic are a little bit, there's some features there, it doesn't always bond very well. I could probably do this better, but this works well enough. So that's on there, more or less good enough. So yeah, then, you know, we'll be attaching when this is all painted and done, we'll be attaching the front plate, that little kind of shield shaped armor plate right here, and it kind of sits right in place below the ring of the bearing very well. So this is, you know, this design, when you're done with it, you know, it looks kind of silly right now, but when you're done with it, you know, you can see on this one how that kind of connects. It hides the servo box very well. You know, there's a little bit of overhang on the bottom and on the sides, but, you know, you don't see it, and it looks great. It's, you know, these are very distinctive looking models, especially when they start dancing, and nobody cares about a little bit of servo hanging out. So, all right. Here we are. We've got the legs fully bonded to the base. Now, the urge is, of course, to immediately stick this top thing on top and say, look at my robot. Don't do that. We really want to get this wired up to the microcontroller on the inside. Get that thing ready to go. Just do a final calibration on it before gluing anything to the top. So let's do that now. I'm going to go ahead and turn on my soldering iron because we will need it. Fortunately, the servo has plenty of length on the tail. And that's great because that means we won't have to extend it with any wires. So what I'm going to do now is we're not going to use the connector here, so I'm going to snip this off. We're going to be soldering this directly to the microcontroller. Snip, snip. So now we just got these 3 wires. So there's a number of ways you can do this, and, you know, it's really down to artistic, you know, what you think looks cool. The rule of cool still applies here, even though we're doing some low-key engineering. So what I like doing is winding this cable through the features of the legs. You've got these little plastic bits here. Just, you know, this isn't going to be under any rotational stress because the servo is turning it's going to be turning the torso rather than the torso turning the legs. So this is going to be all static. So we don't have to worry about this flexing at all. But, you know, I just wind this around the leg. It'll all be the same color because we're going to rattle can this when we're painting it, or you can hand paint it. You do need to prime it though. You need to prime these wires because otherwise the regular paint, the little paint pot paint won't stick to it very well. So I'm just threading this around and try to get it nice and tight. It's not too hard to do. So I've got the wire kind of wound around there. It doesn't look very tight now, but it is. And you can have this go to ground anywhere you want. Basically, we're trying to take this cable and make it reach the plate. So we can drill it through anywhere we want. Just make sure you leave room for the ankle plate to go on. You don't want to have the cable going across like this, because then the ankle plate won't fit on properly. So I'm probably going to have that kind of go down the back here. And you can do, you can have this cable, you can glue it directly to the sides here and have it flush, or you can just have it kind of hanging out. It really doesn't matter. It's, let me just adjust this a little bit. It's up to you. Whatever looks cool. You just want it to be secure. So what I'm going to do now is take a few drips of glue and glue the cable to the side of the leg, just to keep it from flexing anymore, and just kind of bind it in place. And just to tighten it up. This process can be a little bit tedious, because you got to let the glue bind properly. Usually hold it for about 30 seconds per drop, and just keep the cable tight. Let's see here. I'm just going to run it right down the side here. That should be out of the way of the plate. And it'll be painted whatever color you want. So these cables blend in very well once they're painted. So it's not like it's going to be this giant German colored cable running down your robot at all times. So just give it a minute. And yeah, it's on there pretty well. It looks really obtrusive right now, but it won't be once we paint it. It actually adds to the aesthetic of the robot leg, because you've just got all this extra cable there. It looks pretty neat. All right, so if you look under here, and then you compare that to the top, just kind of flip it back and forth, you can see that the cable is touching the base very near to our microcontroller, and it's even it's on the wrong side. Actually, no, it is on the right side, because you probably can't see these designations on the board, but this is the 5 volt and the ground pin right here. So this cable is going to come through right here. We can solder this directly on. The yellow that'll be the brown and the red cable. The red cable for the 5 volt and the brown for ground. We will need to probably extend the yellow cable over to the other side of the board, because we're going to connect that to the A0 pin. That's going to be our first PWM pin. So let me go ahead and thread this cable out. I'm just pulling the wires apart so they're not bound to each other anymore. And yeah, that came loose of the glue. That doesn't matter. It's fine. We'll once this is down and drilled into the board, we'll secure that better. Okay, so next step is to find the finger drill in all the pile of debris that I've got on the desk here. Oh, there it is. We're going to drill 3 little holes in the base. It's very, very easy to do. The plastic is nice and soft. Keep my drill bits under control here. Just make sure that the drill bit that you're using is wider than the wire for the servo. Comes with the servo. Doesn't need to be that wide, just so that the wire can pass through the hole that you're drilling without too much resistance. Just finding the ideal drill bit here. This will do fine. We're going to be gluing the wires into the holes anyway. We want to make sure the wires don't move as much as possible. All right. So we decided that the holes are going to go right here, just between these toes. So you want to double check, or triple check even, that you're not drilling into your microcontroller, because that'd be another bad thing to do. So just, put your fingers together so you can feel on both sides of the board, and then decide where you're going to drill your holes. I'm going to drill them right along this toe here in a line, just because I know that the microcontroller is not there. And just, this will drill in with very little pressure. You just got to be gentle with it. And we're drilling 3 holes. Come on. There we go. There's one. Just check underneath. You also want to take the battery out before you start drilling. I should have done that. Should be paying attention. It doesn't matter where you're drilling. Do not drill into one of these cases while there's a battery in there. Trust me. These things, the batteries will, if punctured or damaged, they will go critical on you and blow up. So please don't do that. You don't want to be messing around with lithium-ion batteries. They're just disgusting. So I'm going to drill in these holes. I'm going to get a smaller drill bit because this is too big. Where'd my other one go? Making sure the diameter of my drill bit's bigger than the wire I'm drilling for. Yeah, that's good. Okay. The smaller the hole you're drilling, the easier it'll be to drill. So, all right, so I got my first one drilled. I'm going to kind of set the cap over a little bit so I can see that there's nothing underneath of it that I'll actually be drilling into. And just drill the other 2 holes in. You can also just drill one big hole and run the wires through, but it's harder to secure them on the other side. And it doesn't look, it's not quite as neat of a look. But you do you, whatever's easy. If you're basing the hell out of this thing, like putting a bunch of stuff on top, it won't matter anyway. But I like to keep things clean as possible. Okay. So we've got our three little holes. Whatever. It's never going to focus on that. So we're just going to take the wire and fish one wire into each hole. Again, if you drilled one big hole, it doesn't matter. Just jam them in there. And you can use tweezers to push the wires in if they don't want to go. I mean, it's pretty simple stuff. Just getting all 3 of them in there without pulling the others out is a little bit of a art form. There we go. And once you have them in there, just pull them flush. And now we're going to secure this wire to the foot. And like I said, you can route this wire any way you want. You don't even have to have it running down the leg. You can put, like, if you have some basing stuff behind it, like structures or something, you can kind of run the wire across to one of those. You can do anything you like. It's up to you. It's your model. I just run it down the leg just because I don't base these things immediately. So I just want the wire secured, and I like the look of having the extra cabling dialing down, snaking down the leg. It looks kind of cool. So I'm gonna put just a bead of glue around each of these wires going into the base, just so they're secured and they're not going to pull out. Then we're going to let everything cure for a minute. Yeah, pretty good. So that's what it looks like. You've just got the wires just running down there. It looks really garish right now, and it looks like it'll stand out a lot, but it won't. Not once you're done. So while that's curing, I'm going to go and on my other screen, make sure I've got the firmware for the CircuitPython board. Okay. Yeah, so the CircuitPython, the CircuitPython firmware is going to depend on what microcontroller you're using. So if you're using ESP32-S3, it's going to be different than the one that you're going to be using for the S2. You're going to any microcontroller that you want to use, make sure it can run CircuitPython, or you can write the code for this thing in C. You can write it in Rust. You can write anything you want. Just make sure your microcontroller can run the language that you want. I like CircuitPython just because it makes messing with servos, messing with LEDs, and just anything trivial, because Python's an easy language, and it just makes the entire process painless. So I'm going to go ahead and load the CircuitPython firmware onto this microcontroller. The way that works, I'm going to try and show this. I'm going to disconnect our power plug from this and connect it back to the computer. And the procedure for doing this is on the Adafruit website. So I'm going to look for the boot button, I think it is. There's two buttons on this. There's a reset button and a boot button. So I'm going to take the boot button. I'm going to press that, disconnect the microcontroller from power, plug it back in, and we should see hold on. Did I do this right? I think it's you hold the boot button down for a couple seconds, and then disconnect power, release it, reconnect power. I'm doing this wrong. Yeah, I'm doing it wrong. Let me look this up real quick. All of this is documented on the Adafruit website, and I'll link that in just a second. I'm just going to grab this browser and put it over on this screen so I don't have to cram my neck. All right. Just bear with me here. All right, so the procedure, if you're using the same microcontroller as I am, the ESPP QT PY ESP32-S2, this procedure describes how to put CircuitPython on it. So I'm going to do that now. It's the reset button. We want plug your board and computer using a no good cable. Click the reset button once, and then click it again. You'll see the button turn, the power light turn green. I'm going to do that now. Let's see. Okay, so you just got to hit the reset button on the microcontroller like once, and then once the light turns purple, you click it again. Now, what that does is it brings up. Normally, when you connect the microcontroller to your PC using USB, it will show the contents of the code directory. So you can put your code on there. You can modify it. You can use the move program to change your code. When you click when you do this procedure, and the light turns green, it dismounts the code directory and puts up the bootloader directory. So at that point, let me share my. Nah, I can't share my screen right now. But anyway, what I'm doing is I've got the firmware. You can just download it from that article I linked, and I'm just going to drag the firmware file over to the boot directory of the boot drive of the microcontroller. And once that uploads, it'll automatically reset, and you'll be running the Circuitpython firmware. Super easy. I'd show you here, but I'm not really set up for it. I need to set some new scenes up. Okay, so I copied the firmware over, it rebooted, and now we have our environment ready to go. You can see that CircuitPython's detected the board, and if I save this code to it, it saves just fine. Let me see the serial output here. Yep. Okay. So let me change to the code view. All right. So now that we've got CircuitPython on here, I've saved this program onto the microcontroller. You can see right here that immediately it throws an error saying that no module named Adafruit Servo Kit. Okay, so there's another step that we have to do before we can actually do anything with programming this robot. That step is to download the driver library for the for CircuitPython. You can get that from Adafruit's site. If you follow the link that I linked with, that I'll put in the YouTube comment as well, that I just put in Twitch chat. Let me put that in there again, just in case. If you follow that link, this describes how to get the library bundle and to put the appropriate libraries on it. I'm just gonna, for the sake of quick brevity here, I'm gonna do this real quick. Just drag everything to the right screen. So the stuff we want is going to be Adafruit Servo Kit. I'm going through the driver library now. It's really just a RAR file full of drivers. And you're just, there's nothing complicated about this. This might seem a little bit intimidating if you could see what I'm doing. Let me fix this. Hold on one sec. How do I add another layer? Hold on. Layers plus add a layer. Main screen share. Okay. All right, let me drag the stuff to the other screen again. We can't see. Oh, hold on. That's odd. Okay, I don't know what I'm doing with this. Anyway, I'm dragging a bunch of libraries into the into the the library folder of the microcontroller. I'm just got to find the right drivers here. It's the servo kit driver. Where is it? You were up here somewhere. I'm just scrolling through a RAR file right now. Really, this is kind of outside of the scope of this video. I really should have done this before. Where is this? Oh, it's Ada kit motor. Yeah, there it is. Okay. Okay. Actually, what I'm going to do is I'm just going to, rather than doing this, I'm just going to disconnect this, and I'm going to reconnect the test rig and pull all that stuff off of there. That's already set up, ready to go. I'm just going to copy all of these files, put them somewhere temporary. And then I'll copy them onto the other microcontroller. All right, so let me reconnect the other microcontroller. I honestly should have done this before we started going live, but whatever. All right, so I've copied all the drivers over to the microcontroller. Doing that now. And we're good. So yeah. So I'm going to save this to rerun it, and I'm going to check the output. Okay, so the code here is a little bit different because I don't have an I2C controller here, so I'm going to modify this. Oh, what was the code? Damn it. I'm trying to remember how to do this with this other board. Servo kit. So I'm looking at that Circuitpython link that I gave earlier to see if they have the. I really should have had this code. I wasn't expecting the. I forgot that this is going to be slightly different. Okay, so STL, SDA, SIO. Okay, that's not right. No server kit there. Just one sec. Okay. I apologize for that delay. Let us do our thing. All right, so this code that you see up there right now, do you see code? Yes, you do. Okay, cool. This code you see right here is still set up for the board that I had on the test rig. So I'm going to replace that, create a PWM channel. This is going to be on A0, which is the pin on the microcontroller. We're going to solder that wire in. The rest of this looks good. And then we've got to do the actual calibration call to move the servo. None of this is soldered in right now, so it's really not going to do anything. But I want to have this code here for when everything's soldered in. All right. Okay, I'm just copying some example code. It's been a minute since I've done this, so I just want to make sure I've got it right. Yeah, I mean, you barely even need to know Python to do this. I write Python as every day at work for a living, so it's like I know what I'm doing. I just got to get the actual syntax to do this stuff. Make sure everything is looking good. We need to include servo kit. Okay, I'm just going to put some includes here. So we're importing PWMIO, Adafruit motor, servo, making sure everything is looking good. Okay, yeah, this should run. Let's see what it does. Okay, so as you can see from the serial terminal there, everything is good. The code is running on the microcontroller. So now what we got to do is actually solder this thing up so that it actually does something. So I'm going to disconnect the computer from our microcontroller. I'm going to turn the lid so it's kind of, by this time the legs are firmly on there, so I can rest this on there. And then I'm going to start trimming wires here so we can solder them. All right. So I don't think we'll be able to see any of this without the microscope. So let me see if I can get this thing under the microscope. Move my equipment out of the way here. All right. Let me see if I can get this to work. Oh, what is it looking at? Is my bench microscope messed up? Come on. Yeah, hold on. Okay, there we go. I don't know what the deal is with that thing, but it's good now. All right, so as you can see on the board, we've got the 3 wires coming out. We've got the yellow, that's the PWM wire. We just set up the PWM. We're going to try and get this over to A0 here. We've got the red wire, which is our power wire. We're going to get this over to the 5-volt terminal. And we've got the brown wire. We're going to get that over to the ground terminal. We're going to break the ground terminal out a little bit because we're going to have more stuff to attach to it. So let me figure out how to do that first. Yeah. All right. I don't really have to do that, but I do have to trim these wires first. So I'm going to move this off the microscope, but you get the idea. So we're just going to do 3 solders into those points. So what I'm going to do now is trim these 3 wires so they've got a little bit of wire sticking out the end of them, not just insulation. We just need a few millimeters of wire to solder on, so just going to clip these. All right. The yellow wire, I'm probably gonna have to extend a little bit because I don't think I'll be able to reach that over. So I'm gonna trim that a little bit longer. And it'll just be 4 solder joints rather than 3. All right. Let's do the power first. It's going to be difficult to show doing this because the angle is going to be weird and the desktop camera is not really great. But generally, as I said, I'm attaching the brown wire to the ground port on the board. I'm going to do that first. And I'm going to do it in such a way that I can attach another wire to it as well. Just got to make sure this is not splayed out. I'm twisting the end of this wire so it's nice and straight. I'm going to stick it in the cancellation of the board. Where is my flux? Here's my flux. Just going to put some flux. All right, so now I got to get my soldering iron, put a little bead of solder on the end of that thing and solder that in. Soldering iron's all twisted. All right. Just getting a bead on there. And just double checking where I'm putting my wire so I don't solder to the wrong port. Kind of put it there. And in we go. Probably can't see it, but I've got a nice solder joint right there. That's nice and secure on the ground terminal. So now I need to put the red wire onto the 5-volt channel. It's easy enough. Same procedure. Bend this over a little bit so it goes in the hole even. Come on. Doing this at a really awkward angle. Come on. Key to do this is that we put the wire in the hole without bridging it across any other pins. I'm just gonna. This really doesn't want to go in there. Oh, come on, this is unbelievable. What did I ever do to you? Ugh. All right, whatever. I'm just gonna rebend this the other way because it doesn't seem to want to go that other direction. Holy shit, why is this being so irritating? All right, get in there. Am I missing something here? Is like a spur on this wire? All right, so it's sort of on there. I'm hoping once I solder, it'll be good. Bit of flux to make everything flow. And now soldering iron. Awesome. All right, that's on there finally. So we've got our power and our ground soldered in here. I'm gonna bridge the yellow wire across just with like a 1 or 2 inch length of wire. This wire is great because you just pinch the insulation right off. It's really, really soft. Let's do that on both ends so we have wire exposed. So I'm going to kind of twist this around the PWM wire and just extend it by about 1 inch because it was almost long enough but not quite. Twist these wires together before soldering them. Just curl them over a little bit. Flex them. You really need to resist the urge to just keep the wires twisted and not solder them because they will come undone eventually. And then you'll have to take the thing apart and fix it, which sucks. But, you know, joining wires together like this is just easy. All right, so that's together. I'm going to put a little bit of electrical tape around that, or actually just tape it down to the, once it's soldered in, I'll tape it down to the base. So this piece, this little wire extension is going into the A0 port on the microcontroller, which is going to be our, if you recall the code that I just wrote, that's going to be the pin out. The pin we told the microcontroller to use as its as a PWM pin. The cool thing about these microcontrollers is that you can tell it any pin to do anything in most cases, and it'll work just fine. There are some exceptions, but it's a little bit beyond the scope. Like, little too technical for this, but these microcontrollers, they have these 4 analog pins, which can be used for, since we're not doing any analog operations here, we're just using it for PWM. That works just fine. And because we're using CircuitPython, you can reference the pin in the code as whatever the name of it that you see on the board. So there's no guessing about which pin you're referencing. It's just the same. That's one really nice thing about CircuitPython. Oh, come on. Oh, jeez. Angles were all wrong here. It slipped out of the hole. There we go. Try again. All right. Using flux really makes the soldering to be very, very easy. It just flows right into the hole and bonds. So that's in there. Let me tape this joint down. You don't want to have exposed joints like this because when you put this together, that can contact something on the power converter or the battery, and it just you're in for a bad time if that happens. Like a short circuit like that, it's not a good idea. I mean, technically, it may not do any harm because it's all 5 volts, but you could be putting 5 volts at 1 amp into a circuit that really is only expecting 20 milliamps, and that's not a good thing at all. You get some magic smoke at that point. All right, so I'm just cutting off some electrical tape here. Just gonna tape this open solder point down to make sure that it stays nice and out of the way. Let's trim my tape here real quick. There. So yeah, you can see the electric tape there kind of keeping everything tidy. All right, so the real question is, will any of this actually work? That is a very good question. So what I'm going to do is I'm going to reconnect the power coming from our setup here into the microcontroller. I'm going to reconnect the battery because we need power for this thing. So the battery goes right in. We're done drilling on this board anyway for now. So the battery just goes right back in there. And just going to nestle these wires back in there properly. All right. So if you'll recall, the code that we had running on this thing just sets the servo to 90 degrees. So we want to make sure this thing's actually working. So what I'm going to do is take the little top plate. You can see it's at 90. Our alignment mark is there. I'm going to turn it. So I know that when the code runs, if it runs properly, this will snap back to 90 degrees instantly. So let's take a look. See if our robot is actually a robot and not just a miniature grenade that I'm holding in my hand. Hello? Hello, computer. What are we doing here? That's interesting. Not a big deal. I turn the thing off. Probably some error in the code. All right, so I'm disconnecting the power, and I'm going to reconnect it to I'm going to reconnect our microcontroller to the computer to see what's going on. You'll have to repeat this process. It's not a big deal. Maybe our solder joint isn't right in the. Come on. All right, let me see what the computer says. Yeah. Okay. That's odd. Okay, so what? Now it's time to troubleshoot because this is not working the way I expected it to. All right. All right. Serial console. Let's reload the code. Change this to code view so we can actually see what's going on with the code. Let me fix the code view because I fucked it up for somehow. There we go. All right, so let's see if we can figure out why this is not functioning. All right, so I'm just going to inspect my work here real quick. We've got that connected to A0. That should be functional. I'm going to get my multimeter out to make sure that we're getting voltage where we expect voltage to be. All right, so what I'm going to do is I'm going to test the 5-volt terminals here to make sure that we're getting voltage to the servo. These rails should be 5 volts, and you can see, maybe you can see from there that we are getting, come on, we're getting 4.8 volts. That's looking good. So why are we not getting PWM signal here? That is the question. So the servo should be wired in. Oh, hold on. Let me make sure I have a time call to sleep this thing. 5 seconds. I think we might have. Hold on 1 sec. I'm gonna feel real dumb if this is what fixes it. I'm an idiot. There we go. So that scenario that I described earlier, where I didn't have the time.sleep call here. So I was issuing the servo to 90. I was telling it to change to 90. That takes a minute that takes just a few microseconds for the microcontroller to process that, but it runs out of instructions. So the program says, I'm done, and it stops everything. So it stops before it was issuing the servo call. So by putting the sleep 5 seconds, it gives the program time while it's sleeping for the servo command to go through. So this is working. I just wasn't paying attention right. So yeah, we have, ladies and gentlemen, we have a robot. This looks finished, right? Okay, so what do we do with this? Let's do a few things. I want to show you, how to, what this looks like when it changes. Let me just copy some code here. I'll leave it on the code view for a moment. So I'm going to copy the servo command block here, and just, repeat it a few times. So let's set this to 90, then let's set it to 0, and then set to 180. Not 1800, that will not work. Okay, so let's keep an eye on these little marks right here. All right, so all right, so let me just change this so it's 1 second instead of 5. That's a little slow. Okay, so as you can see, it's out of alignment now because it moved. So let's run this again. So it goes to 90, then it goes to 0, then it goes to 180. And you can use these calls in loops with specific timing to make it move slowly and smoothly. So if you look at this other robot, this finished one, I'll turn him on. So what this is doing is it's rotating to 180, chop, 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 rotating to 0, chop, 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 and then repeating that sequence over again. And I'm issuing the servo calls to actuate the angles on the servos in very small increments with like very specific timing, so that it doesn't just snap back and forth spastically. It's actually moving in very small increments that are too small to see, so we have smoother movement. And you can issue the same commands to this one, even though it has one servo. So it'll just be able to turn its little torso back and forth like this one's doing. So yeah, that's the servo part. So what do we want to do what do we do if we want to do LEDs? Well, LEDs are really actually pretty simple to do. So I'm gonna move him out, and we'll do an LED. We're just gonna do one for now, because the principle is the same. You're gonna. Well, let's actually recalibrate this so it's facing 90, and I'll actually install the head LED. That'll be really good. All right, so I'm just gonna comment out these other servo calls. And I'm going to rerun this so it points right back to 90. All right. So we're pointing back to 90. We're good. And you can see I've kind of got the USB port, just kind of the cable snaked into the base here because I'm reprogramming it constantly. So what I'm going to do now is I'm going to take our torso. Now that we've got this thing proven working, I'm going to align the torso on top here, make sure there's no junk on it, no sprue goop crap there. So I'm going to glue it in like that. You'll notice that like I said earlier, this has like some flat sides on it. You want to get these flat sides aligned with these little things here. It'll help you keep it straight. And if you've got a little bit of an offset, like we do here, where it's not entirely pointed straight, you can correct that a little bit here, because you've got a little bit of give. So I'm going to turn this face on so I can see what I'm doing. Yep, there goes the head. I'm going to turn off my soldering iron for now, because I don't want to burn anything. Alright, so we've got this thing facing face on. We want to align the head so that it is directly facing us after we've done a 90-degree calibration, which we just did. So we're going to kind of set him right there. Yeah, perfect. All right, so now that we've done that, we need to super glue this thing on. And this is just a flat platform. You just super glue the plastic from the model. You just there's like a ring here. You just put super glue on. There's nothing complicated about this. We're not actually modifying any GW plastic with this build, which is kind of cool. So in theory, if you decide you wanted to just go back to a stock armiger and you want to destroy all your work, you could just pull these legs off here, stick them on the regular plastic hip emplacement, and you can have your model back to stock. That is an irreversible thing to do, though. So you've got to hate yourself to do all this work and then decide you want to go back to straight boring GW plastic rather than spending $30 or $40 on a new model or whatever. So I'm just going to put this guy on so he's angling straight on, and that sticks instantly because it's rough resin against plastic. Make sure it's looking good. Give this guy a second to dry. Starting to look like a real robot now. All right, cool. So next we want to do an LED. So we want to put, I'm going to go and I'm going to cut the head off the sprue and put it together. And then I've got an LED here. These are very, very small LEDs. Let me turn on my bench power supply here. This is a bench power supply. This is a pretty neat piece of hardware. It provides very specific voltages and amperages, and you can do 3 different levels at once. I'm just connecting this. It's got a preset port that does 3v3, 5 volts, or like 2.5 for whatever reasons you need for that for. And then you've got these clamps here. So I'm gonna set this to do 3v3, and then I'm gonna connect my LED. There's 2 pins here. There's the red pin or the copper pin goes to positive. I'm just testing to make sure this LED is good before I glue it into this robot. And then we've got the black, or the silver pin is negative. So I've got this thing here. I'm going to turn this power on, and yep, there we go. That is running a little hot, which means this LED is going to burn itself. That's fine. I've got plenty of them. You can tell it's running hot because it's got a white tinge to it. So I'm going to disconnect this. So what do you guys want? Do you want a red eye or a green eye? I think, let's see, where are my LEDs? All right. Got this other one here. Let's see what color this one is. I've got bags of them that are marked in the right colors, but this one is just loose, so let's see what the deal is with him. Yeah, I mean, you get these things in bags of like 25 or 100 of them. So some of them are going to run at different tolerances than the others. You want a good pure color, not like a slightly white color, because that means that it's going to burn out in the voltage we're using for it. Okay, so this one, this LED, you really can't see it because these things are extremely bright. This is a much more green color than the whitish color that we had before. So I'm going to turn that off. I think let's see. The others have red eyes, I believe. Yeah, the other guys that I made have red eyes, so I'm going to make this guy with a green eye. So I am going to get the head off the sprue and put it together, and then I'll bring it back. So just give me 1 minute to do this thing. I'll be back. All right. Where's the back of the head? I'm just cutting this thing off the sprue right now. Get back in a minute. All right, so let me switch to a better view. All right, so we've got the bits of the head. I'm going to snap these together, then clean it up, and then we'll drill out the eye, and then we'll wire it up, and then we'll be done because we have a robot with a LED, and our objective is complete. So let's get this done. All right. Just gluing that together without gluing my fingers together as well. Or cutting my fingers. All right. So I've selected the eye or the face plate that has this the one center eye. That's fine. Makes it easy for us because we don't have to wire multiple LEDs. So that's what this looks like. He's got that one eye in the center. Then I'm just going to drill right through the center of his face and put an LED right in there with the wires coming right out the back. Easy. And then what we'll do is we'll run another set of PWM wire up the back of this thing, and we'll have it flex. It'll do the flex loop, and then it'll go back into the torso, and then I'll have that wire connect to the front here and power the LED. Fortunately, because PWM runs at logic level, which is 3.3 volts, LEDs also run at 3.3 volts. So the PWM wires alone have enough wattage to run the LEDs. And the way that works is I should be able to show a little bit of PWM signal on the oscilloscope if I get this running right. What that'll show is that PWM turns on and off really fast. That's how it controls dimness. With servos, the servo sees that signal and says how much of the signal is on at a time, and then that's how it rotates. It manages rotation. But I'll see if I can get my oscilloscope to show that in a second. But for the time being, let me just get this eye drilled out so I can attach this damn thing. All right, so we want the hole right in the center of the eye. I'm using the same drill bit I had attached here, which is fine. And just push it right through the back of the head. It's not that far to drill. I'm through the faceplate, drilling into the head itself. Let's keep on drilling. Ah, there we go. The head is hollow, so I just press through that. Keep pressing. There we go. All the way through. Head and a spike. Let's clear out all the drill shavings. And as you can see, maybe we have a hole directly through the center of the eye coming out of the back of the head. And I'm going to fish the LED wires through that. very carefully. I'm going to straighten them out a little bit before I do this. And if I do this right, they come right out the back. So we just pull this LED through. And the cool thing about these LEDs is that they fit very well right there. It's flush. So all I'm going to do is I'm going to push that back up a little bit. So there's about maybe a centimeter of wire sticking out the front of that guy's head. I'm going to get my super glue. I'm just going to put a little tiny drop in the eye. And then I'm going to take that, I'm going to pull that wire and just kind of twist it a little bit so that it coats the cable. And then I'm just going to put the, I know you can't see any of this, but actually let me switch to the microscope. Come on, microscope. Why are you doing this? Okay. Yeah. I don't know why it's doing that. All right. So you can see that that LED is now completely flush with the front of the face. And when I power that on, I'm just going to let it cure for a second, the super glue. Okay, that's fine. I'm going to rig it up to power so we can see what it looks like. Again, with the bench power supply. You don't need any of this stuff to actually do in this project, but it's nice to have. Okay, so he's on there. I'm going to turn supply power, and voila, nice green eye. These things are extremely bright. What we're going to be, this is almost too bright, because if you look at it, it's just blindingly bright. So what I'm going to do is, because we're hooking this up to a PWM circuit, we'll be able to dial back the brightness by reducing the duty cycle of the PWM signal. That is, let's see what that looks like. I'm going to turn that power off. I'm going to stick this head onto the robot. And then I will run some wires, and then we can actually look at a PWM signal. Hopefully. I'm pretty novice using my oscilloscope, so we might not be able to get it to go, but I think we will. All right, so we've got our guy here. I'm going to do the same thing. I'm just going to drill right through the back of this this plate here. It doesn't really matter too much where I drill. There's nothing inside, and we can bend the wires to go through that hole. And then we're going to fix the head in place. All right, I am through. So take the head, those wires, we're going to stick them right back in here. Snake them up through the top. And then I'm going to give the top of this guy's little peg a bit of a trim. All right. So this can be a little tricky to get this in here with the wires, but it's not that bad. You just kind of push it in there. I dry fit it before I actually glue it. Make sure the wires aren't like really obscuring anything. All right, I'm going to drill the hole a little bit lower because it's having to fold up behind. All right, that's through. Okay. All right, this should be a much better fit. Yep. Okay. So I'm going to put some super glue up in there. Just make sure the head is in there straight. And it is. He's looking good. Oh, there's a little collar piece I need to put around there. I probably should do that. Let me just make sure I've got it in there right, not all messed up. Alright, doesn't matter. I can do it later. Yeah, that head's in there. Alright, cool. So we need, in order to do PWM here, we need 2 more wires from the circuit board. These are easy. We're just going to run them up the leg again. So what we need is a PWM wire, but we also need a ground wire. So you can run as many PWM wires as you want, and they all use the same ground wire. So, yeah. Let me go ahead and chop some wire up here. I'm going to run... One sec. Get my black wire for ground. That's usually a good color for ground. And I'm going to use my yellow wire for PWM. I don't want to use red wire for PWM because that red wire typically, at least in my builds, designates voltage rather than PWM signal. So I'm going to give myself about a foot of wire. It's way more than we need, but it's always good to have slack. So we got about a foot of wire here. I'm going to trim the ends of this so I can solder them in. And yeah, we'll be able to show PWM signal hopefully pretty quickly here. Because once we have that initial code working like we do, the rest of this is cake. Everything with this project has gone really, really smoothly so far, so I'm happy. All right, so I'm gonna unplug this thing before I solder it because you don't want to have, plugging. You can solder stuff that's plugged in, but it's just not really a good idea. It's not like it's gonna fry your computer or anything, but it's just not something you generally want to do. All right, so the first thing I'm gonna do here is put put this ground wire on. This is going to be a little complicated because I already put a wire in the port for the ground pin, and there's only one ground pin on these motherboard on these microcontrollers. So I'm gonna have to just kind of solder it in on top, which is fine. It's just not as neat as putting it in a hole. Bit of flux. Make sure the soldering iron's heated up. Clean off that tip. It's getting gross. I've just got a wet sponge that I'm wiping it on here. All right, it's nice and silvery. It means it'll get the solder and hold it better. Get some solder on there. Okay, so we're going to take this black wire here and attach it to the ground pin here. I don't think there's a good angle I can show you this where you actually see. So I'm going to put that on there, make sure it's not bridging anywhere. And just, let's get all splayed. Again, put that there. Not cooperating. Okay, hold on. I don't think I had enough flux there, or it boiled off before I could use it. Okay, we're all fluxed again. Still got my bead. It's probably too much flux, but it's fine. All right, that went much easier. Not the prettiest solder joint I've ever done. I'm going to take this over the microscope and inspect just because I want to make sure I didn't bridge. This is a little awkward, but you can see this black wire is connected to the ground pin right there. I'm going to take it over to my magnifying glass on the other bench just to make sure. I'm pretty sure it's good. I just want to make sure this is actually legitimately not bridging before I plug anything in. Well, it's certainly ugly, but it's it looks like a good solder joint. So now I'm gonna put the second wire we just put together. We just cut. Assuming it's still here. Where did that go? Where did that wire go? I just cut. That's the real question. I throw it on the floor somewhere. Jeez. That's odd. Oh, it must have fallen onto my shirt or something, and it was on the ground over here. All right, so I'm gonna put this wire on the other side. You can see kind of. Hang on. Microscope. It's really weird. It's really awkward because it's my microscope refreshed. Jesus, I just smack this thing. All right, there we go. You can see the yellow cable there already attached to A0. We're going to put the next cable right there next to it on A1. And we'll be able to control that as an LED. And I'll hopefully be able to show you some PWM signals because that's just plain cool. All right. Get my hole flexed up. Who does not love a flexed up hole? All right, that is in there. Let me get the solder. This is a very awkward angle. All right, that looks good enough. All right. All right, so let's reconnect this to the computer so we can, we've got our cables all soldered up. All right, so we've got these two cables coming out the back of this thing. Let's connect the board back to the microcontroller back to the computer so I can write some code. Just a line or two. Jeez. All right, so you saw the thing twitch maybe a little bit. That means it's ready to go. The microcontroller is on, and all right, let me just add a few lines of code here to see if we can. Let me just get some sample code for LEDs because I'm lazy and I don't. All right. Okay, so I'm going to do the same thing as this line here. We're just naming it LED, and the frequency is a little bit different because LEDs require a higher frequency of PWM than than servos do. So I'm going to name that. I'm going to tell the board that that's on pin A1. Frequency of 5 kilohertz. Duty cycle starting at 0. And let me. I'm going to set that duty cycle. And I'm going to do this in hex because these are actually no. I'm going to do it. So these are 2-byte or 16-bit duty cycles. So I'm going to say this is going to be 2 bytes goes to 8,000 is going to be in the middle of the road because it goes from 0 to 16,300 and something. It's yeah. My computer science brain fails me at the moment. Let me get my oscilloscope probes out and we can do some science. Where are those? Where on earth did I put the probes? You can tell how organized I am here. I've got all this stuff everywhere. And no idea what I'm actually doing. Oh, they're back behind the oscilloscope. So, what an oscilloscope does is it should show a waveform here. And we'll be able to see, hopefully, we'll be able to see what PWM actually looks like. This will help us understand it quite a bit more. So I'm going to connect this lead to channel 1. I'm going to turn this damn thing on. All right. So where's it? All right, power switch is on top. So I might have to connect the PWM, the base or the ground line in, but we'll see in just a second. Okay, so I'm just going to run this program again. You can see here I've added the line with the default of 8,000 for the duty cycle. Duty cycle refers to how much of the signal is on, how often the signal is on high voltage. So let me see if this actually works. Okay, so we need to attach the ground wire to the little alligator clip here and hopefully not start a fire. Not at this low voltage. All right, so that's the ground wire. Let's see some waveforms. Okay, so let's see what we can see here. I've got to, that's not going to sustain itself. I need to, hold on, give me 1 second. I need to write some code here. So I'm going to set this to sleep for 20. All right, so yeah, we've got some, let me adjust my oscilloscope here so we can see what it's actually doing. I'm going to need to set it for a lot longer than 20. 200 ought to do it. And let's see if we can actually see the oscilloscope with this. Don't want to melt my anything, so I'm going to be very careful with the soldering iron. Okay, so you can see that signal there. Let me see if I can adjust the... Okay, yeah, that looks good. All right, so you can see we've got the signal. This is getting into some science here. We've got the signal at 8,000, which is exactly in the middle of the road for what PWM will do. PWM is from 0. In this case, since it's a 16-bit resolution on the PWM, it's from 0 all the way up to 16,300 and something. So we've got the signal set at 8,000, which means the distance between these peaks is if I set it, okay, so if I set it to say 3,000, let's try that and let's see what it does. Okay, so you might not be able to see it here, but the length of the peaks here went down significantly. So if I set it to 15,000, you can see they got thicker. Let me just try one thing here. Okay, so we're getting more and more. Oh, this is an unsigned integer. Yeah, that's right. Never mind. So I'm increasing the duty cycle here. So you can see how those peaks are getting wider and wider. And that's out of, so we at this point the peaks are, it's almost a continuous signal. So that's the way PWM works. If you adjust how wide the peaks are, and that tells the LED when the peak is high, that means the wire has voltage on it. When the peak is low, it means it has no voltage on it. So what we're doing is we're adjusting the amount of time per second that the wire has voltage on it. So if I dial this back down to half, you can see that that there's voltage on the wire exactly half of the time. That what this causes the LED to do is to turn on and off very, very quickly. So by doing this, we can adjust by having the voltage be on less of the time, the LED will appear to go dimmer and dimmer and dimmer until it's off. By having it on more, it gets brighter and brighter and brighter until it's always on. So that's the signal that we're going to be supplying to an LED. If you supply that same signal to a servo, there's a little computer chip inside that servo housing that says, okay, we're going to adjust the position of the servo based on the pulse width. So if we're at half, like this would tell the servo to go to 90 degrees. If we go to 0, you can see the signal's all the way off. That tells the servo to go to 0 degrees. So if we go to 63,000, which is like 95% on, you can see the signal. The signal is almost always all the way up. That would tell the servo to go to 180 degrees. It's pretty cool stuff. I mean, this is how this all works under the hood. This is getting way more technical than we actually need in order to turn the light on, but we're gonna. It's fucking science. You gotta love it. So okay, so we're gonna take this off of the oscilloscope, and we're gonna go and we're gonna hook this up and light up an LED. So let me get my bench cam back. And put that. Okay, so you can see the wires here poking out of the top. So I'm just gonna twist these on because I'm gonna add some. This is gonna be probably one of the last videos for this model. I might do another build for the one with the servo and the torso. But for this one, I'm just gonna wire the LED up and do some tricks with it. And yeah, we're almost done with this guy. I've got a lot of plans for what I'm gonna do with this. Um, you'll see probably a thread on Reddit when I'm done with it, but I'm really not gonna show the rest of the build on the stream because it's kind of irrelevant. It's me adding all sorts of stupid shit to this thing and making it ridiculous. And that process takes way longer than I want to stream. So I'm just twisting these wires onto the LED leads here. And this should, I don't, what do we have? Yeah, this should light up full bright. Yeah, there we go. So I'm just twisting this on. Yeah, we've still got the PWM signal turned all the way on, or very nearly all the way on. With LEDs, there's a certain point where it doesn't get any brighter. It's like maybe halfway up the duty cycle. The LED will be on so frequently that we can't see any dimming at all. So let's focus this thing first a little bit. Okay, whatever. So I'm going to dial it back to 15,000, which is about 1/4 brightness. Let's see if it changes. Yeah. Okay. So it changed. It's a little bit hard to see with the camera, but it's definitely definitely dimmer if you look at it, head on. It's not blinding anymore. So let's turn it off. So we're gonna change the code view here so you can see what I'm doing. So you can still see the LED down in the little window there, but yeah. So let me turn this to 0. I'm gonna hit save, and then it's gonna go out. You see, it's out. So if we turn this back to 63,000 or 64,000, we see this. It's blinding again. All right. So you can do all sorts of tricks with this. You can, I'm going to set it back to 32 just because that's a good value. You can make this, pulsate on and off and make it look really cool. Let me go get my other one. I'll be right back. This one's got 18 LEDs in it. One sec. All right, so this guy works best with the lights out. So this one is another armiger. You can barely see that. Let me turn the lights back on. So this one's another armiger that I built. I basically built the entire armiger, then I sawed it in half, and I printed out the other half of the armiger in clear resin. And this whole model has 18 LEDs in it. These are all controlled by the same principle as this one over here. 18 PWM channels. 15 in the clear resin part. You've got 5 RGB LED sets. So 15 in the clear part. You've got 1 in the eye and 2 in the melta barrel here. You can kind of see. And I've just got these randomly turning on and off every 3 seconds or so. But you can do some really cool effects with this because you can independently dim every LED in this model and turn it back on. So I call this the rave armiger. And I'm going to do a video with this, like in the other ones on Reddit, like rocking out to something. But yeah, this is the exact same base. You can see down here, this is the exact same base that I built for the other ones. So, and it's the exact same microcontroller. It's got a lot more PWM channels in it. It's got an extra board in there to do this. But what this shows is that you can do with this base and this microcontroller, you can do anything you want to do. Like there's so much stuff you can cram into these robots. Let me just switch to better view. Yeah, there's so much stuff you can cram into these bases. You know, this one, you know, has got, if you look at the bottom of it, it's got a whole separate PWM board over here with like, it's a mess. It's at least 8 LEDs in this one, and another 10. There's another board inside here that does the other 10 LEDs, but it does some really cool color effects. Let me see if I can get it to refocus with the lights off. That's a little bit better. But yeah, the clear resin catches the light really well. You can make any, you can basically, once you start dimming these independently, you can make any combination of light color and have it be independent on all five points. So it's really cool. This thing looks amazing in the dark. It's like this giant Christmas ornament thing. But yeah, so yeah, now that we've got this guy, he is all lit up. He's got his, you know, these wires are still hanging out. I need to run them up the leg and back through the back. But this is, I'll probably do another stream where I finish up the wiring and do some code tricks with this guy to show, you know, what it looks like, what it can do, what you can do with this, some different movement patterns and some different lighting patterns. But yeah, you can run. The only limitation with this is that you can only have, you really don't want more than like 4 or 5 or maybe 6 wires running when up the legs and back up the back when this is going back and forth, because it'll start to be a bit of a mess in the back. But yeah, I mean, you can use those wires to do anything you want. Because this upper torso is empty on this one, you could use these wires to not run PWM, but use it to run a bus like I2C up to a device in here that does anything you want it to do. You could run another microcontroller up in the top. I mean, there's so much stuff you could do because you've already got your motion in the servo down here. You've got all this space inside this head to make it do whatever you want. You could put a camera on there. Like I've got this other Imperial Knight right here, this big one this is the first project I did, where it's running it has a thermal camera. It can track heat targets. Thermal camera is this little thing right here, that little dot. It generates it looks like, you know, a missile tracking. It's ridiculous. The whole thing is so stupid, but it's awesome. So yeah, you could make your little armiger do that and make, you know, if you've got a heat camera somewhere up here, you could send that signal back down and have the servo track in on heat. I mean, you could do anything you want. You just got to get creative, and you've got to not be afraid of wires and soldering and stuff like that. So it's pretty fun. I love doing this stuff. It's just it's a lot of work. But I'm gonna end the stream. I think we've got where we want to be. We've got this light on the front. He's all glowy. We can change the intensity of it all we want. We can have it, you know, dim, bright, dim, bright. You know, we can have it pulsate. You can, you know, do all sorts of really cool stuff with this. And his torso moves back and forth. I'm not going to mess with it because the glue is still drying. But next stream, I'll show you how to do some patterns. It'll be more of a programming stream, but that's good because we need to show that. And you know, we can have the light turn on and off and all this other stuff. It'll be cool. But for now, it's 11. It's after 11. I'm starting to get tired, so I'm gonna go to bed. And hope you enjoyed the stream. Let me put the GitHub link that has all the STLs and code here one more time, so we can have it for the Twitch watchers, all 2 of you that there are. Come on, YouTube. All right, so all of the code, all of the STLs, and all of the parts lists that I use to build these things is here. When this is on YouTube, this will be linked in. You'll be able to see this in the description. For the Twitch folks, I guess look at the VOD. It's there in the VOD. Just type it out. But yeah, this will be updated with code and STLs as I progress with this model. And yeah, I will get this basically into a spot where it's buttoned up. It looks like an armiger. It's got the arms on it, and it's ready to be painted. But I'm not going to paint it on stream just because that painting these things the way I do takes a very long time. So yeah, that's pretty much it. We've got, we did some science. It was awesome. Didn't set anything on fire. I didn't burn myself or glue my fingers to my dick or anything. So I call that a successful stream. All right. Until next time. See you guys later.